Automatic Addison.
In this tutorial, you are going to learn how to write a function in Python, an essential skill for any robotics developer. Okay, so I've got my terminal window open. Let's start just by talking a little bit. So functions allow us to encapsulate code into reusable blocks, making our programs more modular, maintainable, and testable, qualities that are important in robotics software development. So let's define what a function is, okay? A function is a set of instructions that performs a specific task. It can take inputs, execute code, and return an output. And in Python, to create a function, use the def keyword, def, followed by the function name, and then parentheses. So let's see all of that in action. I'm going to first move to the Documents Python tutorial folder. Okay, and let's open up the code editor. I'm going to open up Visual Studio Code. Need to type my authentication. All right, and let's clear all this stuff out here. And let's begin by creating a file by going to the left side, right click, new file, and I'm going to call it robot_functions.py. Enter. Okay, let's define a function called greet, G-R-E-E-T. This function will take a name as an input and print a greeting message. Here's how you do it. def, greet, name of the function, and then the argument, name. Okay, colon, and let's do print, open parentheses, f, hello, comma, and then name, so we can do the variable substitution. And then let's do an exclamation point. Welcome to the robotics world, period. Okay, save it so you can see all of that. So here, name is the parameter of the function greet. And the code inside the function, right there, will output a personalized greeting message when it is called. Okay, so we've defined our function. Now let's see the function in action. So below the function definition, we are going to call the function by passing it a name. I'm going to do greet, open parentheses, and let's do Addison, Addison, and save. So after typing that, you're going to save your file and let's run it. Let's see what the output is and what should we expect before we run it. So we're going to have hello, okay, and then the name, we do the variable substitution here. The parameters is right here, Addison is what we're substituting in here for the name, and then welcome to the robotics world. So it should say, hello, Addison, welcome to the robotics world. And that's what we see here. Hello, Addison, welcome to the robotics world. So that is your first function. And this example demonstrates how your function can take an input and process it to return a result. Okay, now let's explore Lambda functions in Python. So to do that, I'm going to go back I'm in the regular terminal window because Visual Studio Code will do a lot of autocorrection with Lambda functions. So it's better to just try this example in the terminal window. So what is a Lambda function? Lambda functions are small, anonymous functions defined with the Lambda keyword. They are syntactically restricted to a single expression. This makes them very useful for simple functionalities that don't require extensive formatting and robotics programming. In robotics, Lambda functions can be particularly useful for handling events or data transformations quickly without needing to create separate named functions. This can help keep your code clean and efficient, which is important in complex robotic systems where performance is a priority. Let's start by typing Python 3 to open our code editor right in the terminal. And let's define our variable called multiply. Multiply equals lambda x, y, and then x times y. All right, and we do result. equals multiply 4, 5. Print f, the product is result. Let's go over here. Okay, let's enter. And you can see the output is the product is 20. So this demonstrates how our Lambda function quickly processes inputs and provides outputs without the need for defining a conventional function. Okay, let's clear out our terminal window. Oh, sorry, exit. Okay, clear. And let's open up Visual Studio Code again. Close this. And let's explore how to work with Python's built-in map function. This is a tool that applies a function to every item in an iterable, such as a list or tuple, and returns a map object, which is an iterator. This can be particularly useful in robotics for transforming data efficiently. So whether it's sensor data or commands to actuators, using map can help you manage data transformations cleanly and effectively across various components of your robotic system. Let's start by understanding the syntax of the map function. The basic structure is map, open parentheses, function, comma, iterable, close parentheses, where function is the function that you want to apply to each item in the iterable. So all of that said, let's just look at it in action. It'll make a lot more sense. So go over here and let's type in a new file and let's call it working with maps, .py. Okay, and let's create a function def Celsius to Fahrenheit. Return C times 9/5 plus 32. Okay, so this function right here called Celsius to Fahrenheit takes the Celsius value represented by the letter C right there, and then converts it to Fahrenheit using the equation to convert Celsius to Fahrenheit. It's a basic calculation, but imagine needing to convert a list of temperatures. That's where this map would come in handy in a real robotics application. So now let's use the map function to apply our Celsius to Fahrenheit function to a list of temperatures. So down here, let's do temperatures underscore Celsius equals 0, 20, 30, 40. Temperatures, let's go Fahrenheit. A list, map, Celsius to Fahrenheit. Let's do comma temperatures Celsius. Okay. So let's go through that slowly. So temperature Celsius, that's our list. We have 0, 20, 30, and 40. And then temperatures Fahrenheit, list, and then we map Celsius to Fahrenheit and then temperatures Celsius, just like that. Okay. Now let's print out temperatures Fahrenheit right there. Save your script and press play. So you can see right here, we were able to map 0 to 32, 20 to 68 Fahrenheit, 30 degrees Celsius to 86, and then 40 degrees Celsius to 104 using this syntax right here. So temperature functions equal list. We want the output to be a list, and then we're mapping Celsius to Fahrenheit value, okay, using that method right there, and then the input is the temperatures in Celsius right there. which is 0, 20, 30, and 40. See that? So map, open parentheses, okay. Our function name right there, and then the temperature in Celsius, the input into the function. And that creates a list for all of the values right there. Pretty cool stuff. So you can see how this demonstrates how the map function has been applied to our conversion function to each element in the list efficiently. Okay, let's clear everything out. Let's close that file and let's create a new file, okay? And right now, we're going to create filters. We're going to learn how to use the filter function in Python. What is filter? Filter is a built-in function that offers a convenient way to filter items from an iterable, like lists or tuples, based on a function that tests each item in the iterable to be true or not. This functionality is incredibly useful in robotics for extracting relevant data from a larger data set, such as sensor readings or logs. And the syntax for the filter function, it looks a little bit like this. Filter, open parentheses, function, comma, iterable. Like that. Okay? But let's see it in action. Let's go to right click, new file, and let's call it filter underscore even numbers.py. Let's define a function that checks if a number is even. This function will return true if the number is even, which tells a filter to include it in the output. So def is underscore even, and then num. Say return num 2 equals 0. So this function uses the modulus operator to check if the number has no remainder when divided by 2, meaning it's even. So now let's apply this function to a list of numbers using filter. Numbers equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Even underscore numbers equals list filter, and let's say is even comma numbers. Okay, so we defined our numbers. We say even numbers, and then we have our list. We want the output to be in the format of a list, and then we filter using this function right here, and then numbers is the input into the function. So let's see what the output looks when we run it. Oh, forgot the print function. Let's do print the result. Save. Now let's run it. Okay, 2, 4, 6, 8, 10. So we get all of these numbers and we just extract the ones that have a 0 remainder when divided by 2. Okay. Those are the even numbers, 2, 4, 6, 8, and 10. So in robotics, you might use filters to process sensor data, like filtering out readings that are beyond a certain threshold or that don't meet certain conditions. This helps in focusing on relevant data and reducing noise in the system's output, which is important for performance and accuracy. All right, now let's explore the reduce function in Python, which is a fundamental tool for performing cumulative operations on a list or any iterable. But so unlike map and filter, reduce doesn't come built into the basic set of Python functions. It's part of the func tools module, which we'll take a look at later. And it is very, very good for aggregating data values in a sequence. So let's go here. We have our terminal. We cleared out everything. Let's close this. So let's create a new file and let's call it reduce underscore example.py. Okay, and to begin, put the cursor up there. We need to first import the func_tools module. So let's do that now. Let's go to from func_tools, import reduce. Okay. So the reduce function applies a given function to the items of an iterable cumulatively to reduce the iterable to a single value. This function takes 2 arguments at a time and continues to combine them until only one remains. Now let's define a simple operation to use reduce, a function that multiplies 2 numbers. This will help us calculate the product of a list of numbers. So we go def multiply x comma y colon, and we'll go return x times y. Okay. Now let's use reduce to multiply all the numbers in the list together. So we're going to go to numbers. Let's create our list. 1, 2, 3, 4, 5. And product equals reduce multiply comma numbers. Let's print. Let's do this. F. The product of the numbers is product. Save. Okay, what do we got here? Now let's print this out. So the product of the numbers is 120. So you can see how reduce took our list of numbers and reduced them to a single value by multiplying them together sequentially. So that's how we did it right there. Multiply, function right there, and then the numbers list. So that's how it works. So the first iteration of this right here will take the first 2 numbers, which is 1 and 2, and it will multiply those. So that's 2. Then it'll take that result right there, remember the 2, and then it'll multiply by the 3 right there, which is the next item, to get 6. And then 6 times 4 to get 24, and then 24 times 5 to get 120. So in robotics, reduce can be useful for processing sequences of data to extract single cumulative values, like summing up sensor measurements to calculate an average or total over time, or combining a series of incremental movements into a total displacement. So that's it for this tutorial on the reduce function. Thank you, and I'll see you in the next tutorial. Keep building.